In this video, we will see how we can use case structures in LabVIEW. Case structures are like if then else statements in text-based languages. In this video, we will see how we can use case structures with different data types in LabVIEW. So let's see how we can use case structures with different data types that LabVIEW provides. For example, we will be using Boolean data types. For example, Boolean button. Let's connect this to the case selector, and in this case we can see, since Boolean has only two values, we have only two values in this case selector. An alternate way, a more compact way, is to use another node that LabVIEW provides, which is called select. Select works in the same way that its input, the middle terminal, which is equivalent to case selector, is a Boolean, and if the value is true, then the upper value is passed through, and if the value is false, then the lower value is passed through. We can write a similar code here. If it is true, then we will pass 1, and if it is false, then we will pass 2 through this tunnel. As you can see, we don't need tunnels here. Since both are at false state, the result passes, and if both are true, then 1 is passed. So basically both are equivalent as far as Booleans are concerned. So now let's see how our case structure behaves with the numerics. Let's delete all this previous code. Let's create a new case structure. Let's change the, let's see how it behaves with, as you can see, that if I give it fractional value, for example, if I try 2.2, then it will not accept it. It will give an error. What is the error? Case structure values have wrong type. Some of the selector values specified for cases in the case structure could not be converted to the same type as the selector, simply meaning that it cannot handle these decimal point values. It has converted it to as you can see the quotation mark, it has converted it into a string. It can support very well the integers. So only integers are supported with case structure. So let's convert it to a integer representation. So for our first example, we will select the ending range and not the beginning range. For that you put two decimal points or full stops, two dots, and then your range. For example, we say that we want a range of -1. What this means is that up to from -1 up to any lower negative number. Let's add a case after. Let's say we want to handle numbers 1 and let's say 2. This is how we handle it, by putting a comma between them, comma separated values. Let's suppose we want to show that we want to handle cases between number 3 and 9. So we show ranges by hyphen, 3 dot dot 9. This is how you show ranges. And if we want to add an open-ended range with beginning part known, that for example from 10 to infinity, or until the range that this data type supports. So we put two ellipses or two dots there. So what about any number that we have not specified here? For that we have a default value. We can keep the default case separate, or as in this case it can be associated with already existing code. If you want to separate it, then all you have to do is remove this, add a new case, and tell the case structure that this is the default case. So any number that any of the previous cases cannot handle will be handled here, though in our case that wouldn't be possible, since we are already handling all negative numbers, 0, and all positive numbers here. So let's now see how our case structure handles strings. Let's place a string control on the front panel and connect this to the case selector label. As you can see, it has added two true and false cases, but has placed these quotation marks around them. So either we can write these exact strings, or we can also specify characters, for example, and ranges of characters from A to let's say F. So what LabVIEW will do is that convert this A to its equivalent ASCII number and F to its equivalent ASCII number. It will handle from A to it will handle A, B, C, D and E, but not F. F is not included, A is included. Likewise, since the string can be any number, user can input any string in this string control. So we would need a case where any constant that we have not specified for the case would be handled. It could be handled in an already existing case with For example, in this case, if the string is false, then the code comes in this case, and if the string is any other that we have not specified in the cases, will also be handled here. Or we can just remove this, add a new case, and tell LabVIEW that this would be the default handling case. So now see how the case structure behaves with enums. Let's place an enum on the front panel. Let's add some values to it. Let's go to the block diagram and add a case structure. Let's connect this enum to this case structure selector, and if we drop down this case selector label, we'll see only two values are here. So to add all values, and one of them has been marked as default. So if we add all values, add case for every value, then all values are added. But the enum itself is an integer, as the blue color will show. It's an unsigned word, but LabVIEW creates it specially as the details, as the strings that we have input in the edit items dialog box are also carried by this wire. And also, if we convert this to a type def, then, and if we make a copy of it, for example, create constant, then this type defined enum also retains its values. Some controls do not retain their values when they are type defined, but enum does retain its values when it is type defined, so it can be used to specify states for a state machine. And this combination of enum and the case structure is used in a state machine to specify states and the states handling code. Like enums, error clusters also have a special behavior with case structures. If we connect this error cluster to this case structure, then you will see that we have two cases. One, the green one, is the no error case, and the red one is the error case. So if the downstream VI or the code reports error to this VI, current VI, then this case will be executed. We will write error handling code here. But if no error has been reported, then the regular code will go here. So this is how we can incorporate error handling for downstream errors in our VIs, sub VIs.